Data nerds, welcome to this full course tutorial on SQL. This is the video I wish I would have had when I first got into data engineering. To master this tool, we'll break down concepts into short 5 to 10 minute topics. You'll work right alongside me completing real world exercises to learn not only SQL, but also other in-demand skills like Terminal, Git, and GitHub. After each short lesson, you'll have the option to tackle interview level practice problems that prep you for the job and reinforce your learnings. And by the end of the course, you'll have built 2 fully customizable portfolio projects that showcase your skills in building and analyzing a production level data warehouse pipeline. Now, SQL is by far the most popular tool for data engineers. If we look at recent job postings, we can see that it's in 2 out of every 3 postings for data engineers. And it only increases in demand for those senior roles, making it even more of a vital skill to learn first. Now, SQL or SQL is the language used to communicate between you and a database. It's by far my most used tool as a data nerd. Starting with my first job working for a global Fortune 500 company, all the way to my most recent job working with Mr. Beast. Yeah. Even Jimmy uses it. More recently, I've been using it in my data pipeline for my app, datanerd.tech, but more on that in a bit. So over the years, I've cataloged everything that's essential in using SQL and bundled it all up into this course. Now, to be clear, I've made this for beginners. There's no coding, terminal, or even engineering experience required. I'll be teaching you everything you need to know step by step. For this, we're going to break up the course into 2 halves, with the first half focusing on the fundamentals you need to learn to feel confident writing SQL in a real data engineering workflow. We'll start by getting your environment set up and making sure you can run SQL both locally and in the cloud. Then we'll introduce core query building blocks such as filtering, grouping, aggregation, and sorting data. From there, we'll shift into understanding how data should be structured in warehouses with dimensional modeling. And throughout the sections, you'll use the same tools real teams use of VS Code, the terminal, and Git and GitHub. At the end of this first half, you'll build a portfolio-ready project where you explore a real data warehouse. In it, you'll write SQL scripts to answer stakeholder-style questions, and your analysis will be published to GitHub. And this will ultimately help you start thinking like the stakeholders you'll be building data pipelines for. Now, in the second half of the course, we'll shift into writing SQL the way data engineers use it in production. We'll start with how they build and evolve warehouse tables using create, alter, and drop. We'll then cover how pipelines load and maintain data with insert, update, and delete. From there, we'll focus on data modeling techniques, especially star schema design of fact and dimension tables, so your warehouse is built for analytics and downstream use. And finally, you'll level up your SQL with CTE and subqueries for clean modular scripts, plus window functions for real warehouse analytics and pipeline logic. At the end of this half, you'll build a production-style end-to-end SQL pipeline, designing the tables with the correct schema and then loading the raw data into it, and then producing data marts for specialized use cases that can be accessed by a multitude of tools and prove your job-ready data engineering skills. Now, I believe in open sourcing education, so this entire course is completely free. You'll have access here on YouTube to every video lesson and can follow along with exactly what I do. And everything we're using to run SQL is completely free and open source. Oh, and I've even made both final projects publicly available so you can compare your work to it. Now, for those that want to support the course, I have some perks that add structure, practice, and certification. First, you'll get access to your own course dashboard that tracks your progress. In here, it lets you watch each lesson individually in short, bite-sized segments. Then after each lesson, you'll have access to additional SQL interview level practice problems that provide a detailed solution. However you get stuck, you can leave a comment below and get help from other students. On top of this, I'm giving you all my course notes that walk through the video lessons step by step, and you'll get access to my custom cheat sheets breaking down key concepts. When you complete the course, you'll receive a certificate of completion that you can post directly to LinkedIn. So if you want to support and bring to life more courses like this, use the link in my description to get access to the supporter resources. Now, I have 2 SQL courses. SQL for Data Analytics, my first SQL course. It's 4 hours long and ends with an analytics focused project. And then this course, it's 14 hours long and it has a similar analytics project, but then an engineering focused project as well. So which one should you take? The simple answer is data analysts should take the first course and data engineers should take this one. Now, neither course is a prerequisite for the other. Both courses teach the same SQL language, but they implement it differently. SQL for Data Analytics focuses on querying existing data to answer business questions. And then this course starts similarly, but it ultimately focuses on building production level pipelines, framing this all from an engineering perspective. If you've taken SQL for Data Analytics and want to take this one, go for it. You'll still benefit. Early sections may feel familiar, so skim ahead if those concepts are already solid. Now, this course was a behemoth to make. It's over 14 hours long. It took me the greater part of last year to make, and it took a team of 4 to put it all together. So I'd be remiss if I didn't give a shout out to these teammates. For this, we're gonna do it the office style. Ricky, my content developer, did a lot of work behind the scenes putting together those SQL interview practice problems. Brandon, my video editor, helped condense down about 100 hours of video footage into 14 hours. And finally, Kelly was the producer of the course, helping out with both lesson and interview practice problems. So shout out to my team for helping me bring this together and make this course possible. All right, one last thing before we jump into the course. If you get stuck along the way, I highly recommend you use any popular chatbot, as they're more than proficient in SQL and a heck of a lot faster than waiting on me to reply. Anyway, enough of me yapping. Let's get into this course, diving into our first concept to understand what SQL actually is. All right, in this lesson, we're gonna get you up to speed in understanding everything you need to know behind this powerful tool for data engineers. To understand this, we need to grasp 2 major concepts. First, where do you write and execute your SQL queries? And secondly, your database, where your data's actually stored. So let's dive into that first. A database is a collection of data, and these things were made to hold a massive amount of data. An Excel file spreadsheet can only hold around 1 million rows, but a database can easily hold way more than that, 9 quintillion rows. Now about those databases, there are 2 main types of relational and non-relational. We'll explore each type more in a bit. But first, let's go back to where we're actually running SQL. When you write this code to request data from a database, that's called a query. And SQL can do a whole heck of a lot. A common acronym associated with this is CRUD, and it stands for create, read, update, and delete. With SQL keywords like create and insert into, you can add new records. Then with keywords like select, you can retrieve specific data you want. Next, with keywords like update, you can modify existing records. And then finally, the scariest of all, if you need to remove records, you can delete it. Now these commands fall under 3 types of SQL commands. DQL, or data query language, is used for the reading aspect of CRUD and is what we'll focus on the first portion of the course. Next is DML, or data manipulation, and this is used for creating, updating, and deleting new data, specifically in tables that already exist. Then we have DDL, which is data definition language, and this deals with creating or deleting the schemas and tables we need from scratch. So understanding this, we can now understand how SQL actually works. From your computer, you write a SQL query and send it to a database. The database then performs your CRUD operation and then provides you a SQL output, depending on what you did, to your computer. But this now begs the question, where are databases even stored? Well, there are 2 main options. You can either run it locally or in the cloud. Local means the database runs directly on your computer. This is ideal for data engineers to iterate quickly without affecting production databases. However, others can't access it. Now, production databases are usually stored in the cloud. This enables your entire organization to connect to the data source you built. You've probably heard of popular cloud providers like Google, Amazon, or Azure. Anyway, we're going to be using a combo of both local and cloud for this course. And in the final project, you'll be building out a data warehouse and data mart locally and then push it to the cloud to make it publicly available. So now that we understand that databases can be stored on your computer or in the cloud, what are the different databases we can store in these locations? Well, 2 main types of relational and non-relational. Relational databases store data in rows and columns, very much popular in analytical applications. Say I have a database of job postings that companies go to daily to update on what jobs are available. You could have one table to keep track of all the different jobs, and then you have an associated table to keep track of all the different companies. There would then be things like a company ID within the 2 in order to relate the different tables. Hence, relational databases. Now, this course will primarily focus on using SQL to interact with relational databases. But it's important to know the other type of database of non-relational databases, commonly known as NoSQL. But NoSQL doesn't stand for not SQL, it stands for not only SQL. These support storing your data in a variety of different forms, including key value paired, column-based, graph-based, and even document-based. All right, so we understand the types of databases now. Because of that, we can get into narrowing down what database we're actually going to use for this course. Well, it needed to meet a few criteria. First of all, it needed to be a relational database that was also highly popular, so it has a community for support. From there, I started to narrow it down to a database focused on analytics to make it support building data warehouses. After this, I narrowed it down to free and open source options so that anybody taking this course can use the database. And finally with that, I needed this database also to run locally first, along with the cloud. And so this gave us DuckDB. DuckDB is a blazingly fast database that satisfies all of our needs. So we're going to be using it for the entirety of this course. We're not only going to get you set up with running it locally on your own computer, but we'll also run DuckDB in the cloud by using MotherDuck. This is a managed cloud platform that will be completely free to use as well. Now this brings us back to the last concept we need to cover of where we're going to be writing and running these queries. Well, that's commonly done in an editor, whether that's database provided, cloud provided, or just a standalone code editor. Now, database provided ones provide you with an application to use on your computer to access their local database or cloud-based one. This is a popular option from Postgres called pgadmin, and inside it even allows you to write SQL queries. For data engineering work, I'm not a fan of these. Next up are cloud provided editors. Typically, you access them in a web browser, and they allow you to interact with your database. We're going to be using MotherDuck's cloud provided editor in order to connect to our needed databases for the course. We'll actually do this for the first half because it's super easy to get up and running for you. Last up are code editors, and this is what we'll focus on for the majority of the course. We're going to be using a popular option of VS Code along with the terminal, which allows you to build all your SQL files locally, but then interact with databases that are either local or in the cloud. You'll be running SQL queries like a pro data engineer after this. All right, so now we understand what SQL is and what tools we'll be using for the course. But it now begs the question, what data are we gonna be using and what pipeline are we going to be building for this course? Well, covering that next. Welcome to this lesson. We're going to be diving into understanding what data and also what pipeline we're going to be building for this course. But before we talk about any of that, we need to understand what problem we're trying to solve. And it's a real problem that I had. This all started a few years ago when my subscribers were asking, what are the top skills they should be learning in data? And the best way to answer this analytical question is to look at where these skills are demanded. In job postings. So I built out a data pipeline that solves this. It pulls online job postings from a source and then using SQL cleans up and transforms this data. Finally, it then loads it into a data warehouse. Now I'll go into this data source and how I built the pipeline in a bit. But first, what's a data warehouse? Well, in order to qualify, it needs to be subject-oriented, non-volatile, integrated, and time variant. If it doesn't have these four things, it's just a database and not a data warehouse. This is all from the father of the data warehouse, Bill Inman, and we'll be going over this definition in much more detail as we build out our projects. Anyway, for our final project, we're going to be replicating what I did by taking raw job postings and building out a data warehouse and also data marts, all with SQL. So what does this data look like inside of our data warehouse? Well, here is an ERD, or Entity Relationship Diagram, and it shows the different tables in here. We have 4 major tables. One fact table containing all our different job postings, then a dimension table around the different companies that are posting jobs, and finally dimension tables that contain key information about the skills required for these jobs. Now, if you haven't heard about fact tables, they contain the core data for our analysis. They measure and record actual events, so in our case, the different job postings. The dimension tables describe attributes or dimensions of the data. In our case, skills and company information. And this is really important in supporting filtering and grouping different sets of data. Anyway, that's all theoretical. Let's actually dive into my machine and look at the key attributes from the data. So querying this data warehouse, we can see that we have 10 different jobs available to look at job postings for. Data analysts, data engineers, and data scientists are by far the most popular, but there are other options available. And with that, these postings come from around the world in over 160 different countries. So the country you live in probably is in this data set. And this now begs the final question of, what platforms did we get all these job postings from? Well, a ton of popular options like LinkedIn, Indeed, and even ZipRecruiter. So you're probably wondering, where the heck did this data come from? Honestly, it wasn't easy. Back in 2022, I wanted real data on what skills actually get you hired in data jobs to provide to my subscribers. Not opinions, not blog posts, but real job postings. So I did what any data nerd would do. I tried to scrape LinkedIn. So over the course of a few days, I built a scraper, learned just enough front end to make it work, stayed logged in with my LinkedIn account, and surprisingly, it worked. Well, for about a day. Then the CAPTCHAs started to hit. Then my account got banned, and it became obvious real fast. Job posting data is extremely valuable, and these sites protect it aggressively. And this is a very real data engineering problem. Scraping at scale quickly turns into an infrastructure nightmare. So at this point, I thought the project was dead, but then I happened to stumble across SERP API, and they had exactly what I was looking for. Instead of scraping LinkedIn directly, SERP API gave me access to job postings at scale through search engines. So SERP API can pull these jobs from Google that ultimately come from different platforms like LinkedIn, Indeed, and ZipRecruiter. So with this, I wasn't fighting CAPTCHAs anymore, managing accounts, or building infrastructure. On a whim, I reached out to SERP API, explained my problem, and asked if they could support the project.
You've got mail.
Surprisingly, the CEO himself replied, and they agreed to support the project. So I immediately started by jumping into their platform and building out the code in their playground area, which lets you test out different queries and see the results. Clicking search, I can see the search results that it gets back in this browser view, but what's actually more useful are these structured results that I get back. For example, with this first one, I can see it's a senior data engineer role in Washington, D.C., scraped from LinkedIn. It tells me that it's not only full-time role, but also in the job description, I can see it list a host of different skills. This right here is the jackpot. Oh, and some jobs even have more information, like this one with salary. Honestly, this is way more detail than I could ever have gotten by scraping on my own. From there, I can grab a code template for any popular language or tool, such as Curl, Python, or Google Sheets, and I can run it locally or in the cloud wherever I need it. Now, to be clear, SERP API has way more than just job postings. They support over 50 search engines, everything from things like Google Flights to Google Maps to product listings on sites like Amazon, and they even have an ability to look at YouTube. If I wanted to, I could scrape all of my YouTube data and get it back in only a few seconds. Oh, and if you need responses in under a second, they also offer add-ons for that. Now back to my job data. I've been systematically pulling these job postings on a daily basis, which is how I've collected almost 5 million jobs over the past 2 years using SERP API. All the data can be accessed via my site, datanerd.tech, and it solved my problem of figuring out what skills data nerds actually need to get hired. It's how I figured out that SQL was the most popular skill of data engineers. And all of this job posting data that I've collected over the years we'll be using throughout this course in order to learn SQL and ultimately build a SQL-based data pipeline. Now to wrap up, I want to give a huge shout out to SERP API for sponsoring this video. Use my link in the description and tell them Luke sent you to get 20% off. They even have a free tier with 250 searches per month to try it out. Now, enough of me yapping. Let's get into setting up SQL on our computer so we can start playing around with it. All right, see you in the next one. Welcome to this lesson where we're going to be not only going through setting you up with the environment in order to execute SQL, but also get you set up with the actual database that we're going to be using for the entirety of this course. And jumping into my computer to show you this, we're going to set you up in the browser in order to be able to execute SQL queries. Here I have the results right below here. And you're going to have this environment here that we're working on in the first portion of the course in order to investigate and learn some different SQL syntax as we go through this. Now I'm going to get you all set up to be able to execute SQL in your browser and with the data set. But before that, we need to understand some concepts of actually where we are running this SQL query. Well, as you can recall from the last lesson, we're going to be using the free open source option of DuckDB for this course. And this is a very lightweight database that you can run right inside of your computer. Now, DuckDB is relatively easy to get set up and installed on your computer, but it requires one pretty big caveat. If I go into the installation guidelines, it tells you how to install it, and specifically, it has you installing it with a terminal. And I'm assuming for a lot of you taking this course, you don't have much familiarity with running commands in the terminal, and there's quite a few to get set up with not only DuckDB, but also the dataset. So because of that, I made an executive decision when making this course that we're going to start out working in this web browser environment that has DuckDB on the back end, and this is called MotherDuck. Now, MotherDuck, which you can visit via this link here, is the commercial SaaS or software as a service platform that supports running DuckDB in the cloud, or if you will, in your browser. DuckDB or DuckDB Labs owns a significant equity stake in MotherDuck. So it's very beneficial for both of them to work together and collaborate. Mainly, they keep it separate so DuckDB team can focus on improving the database and keeping this free and open source. And MotherDuck is the commercialized version that actually makes money to keep DuckDB Labs funded. And probably the most important part that is relevant to you, MotherDuck allows us to host DuckDB databases on the cloud, basically have data warehousing capabilities. And then you can use other popular services in order to connect to these DuckDB databases inside of MotherDuck. For me, coming from a data analysis background, this is pretty imperative because tools like Tableau and Power BI can connect to a single source of truth inside of MotherDuck. And there's a host of other data engineering tools that we'll eventually get into later on in the course that can connect to it as well. So to recap, DuckDB is a free open source software that you can run either locally or on another server. Whereas MotherDuck is the platform that allows you to host these databases in the cloud, basically host data warehouses. And honestly, I wouldn't have known about either of these services if it wasn't for Mehdi. You can check him out at the YouTube channel here. He heard that I was building this course on SQL for Data Engineering, reached out and connected me not only with the MotherDuck, but also the DuckDB team in order to put this course together and make sure it was successful. So huge shout out to him. Now let's get into setting up your MotherDuck account. And for this, we're going to be on the free tier. We're going to remain on the free tier for the entirety of the course. And the good thing about MotherDuck is there's no credit card required. All you got to do is just sign up. For those complaining that you got to sign up for a service in order to take this course, as a data engineer, you're going to be signing up for a lot of services, and a lot of them don't offer free tiers. So consider yourself lucky with this one and get used to it. For this, you're going to navigate to the URL on screen of lukeb.co/MotherDuck. Now, the MotherDuck team has built this special login for us and the course takers of this, so that way we can skip the normal marketing emails that you get if you logged in through motherduck.com. Anyway, you'll sign up by either putting your email below, or I recommend using something like GitHub, or like I'm going to do, Google. From there, go through the authentication process with Google and your associated Google account. From there, insert your name, organization. I just put Luke's organization. For me, I'm located in North America. That's where I want the region to execute my different queries. And then from there, click continue. From there, you may be asked a few questions about your background. Feel free to just fill it out or skip where applicable. And then from there, it has a hey, let's get started. I'm gonna go ahead and just click all of these and say that we did them because we're gonna go through them in this. So now we're inside of the environment where we're going to be running SQL queries. Take note of this URL that where we're going to be at for executing this, so you can come back to it easily. Let's get into understanding the UI or user interface of this MotherDuck experience. Now it's broken into three major parts. Over here on the left is what you'll hear me call the left sidebar or the sidebar. In the middle right here is our SQL notebook, and we can actually add different notebooks as well in that sidebar. But that's where we're going to be executing those SQL cells, which we'll get into a little bit. And then we also have on the right-hand side something called an inspector, which we can go into inspect datasets. I'm going to leave that open for the time being so we can get into that. I'm going to go back to that MotherDuck notebook right here. Let's dive into that left sidebar a little bit further. They have capability to just do search. So if you have a certain term, you can search for it. We can also create tables from files. Then in that notebook section, I can either hide or show it. We just created this untitled notebook. I'm actually going to rename this notebook, and we'll just name it after what this section is. Specifically, we'll call this SQL and Database Setup. And then I'll click Rename. Feel free as we go through these different lessons to create different notebooks to keep track of what we're doing. Underneath these notebooks are our attached databases. And right now we only have two. We have a My Database and nothing inside of it. And then we have some sample data sets. And we'll explore one of these to explore the notebook here in a second, but I want to call out this. Down at the bottom, you may see something this of, hey, your trial ends in 21 days. Don't worry about that. You will stay on that free plan, and the course will, or this platform will be continued to be free to the entirety of this course. You're not going to use enough resources to need to upgrade, so don't worry about that. So I'm just going to minimize this. Before we dive into those databases, it's important that we understand how hierarchy works in a database, specifically for tables and different data we have inside of it. So for a database, you can have one or multiple different schemas. We're just simplifying it here, but only allowed to have certain tables within that schema. So schema A in this case could have table 1, 2, and 3, such as users, orders, and products. And then table or of schema B could have something like employees and products in a separate one. You can keep it separate from each other, but in the same database. We'll apply this to our data set that we're going to be using for this course in a bit. But I wanted to go over that because if we look inside of here, we have something like MyDB, and it has the schema of main. Similarly, underneath the database of sample data, it has 6 different schemas. And then if I go to something like the Stack Overflow survey, it has 2 different tables inside of that schema. So what I'm going to do is I'm going to go to that survey results of the Stack Overflow survey. And what I can do is click these 3 dots right here. And it allows me to query in the Curtin notebook. I'm in the Welcome to Mother doc. That's fine. I'm just going to go ahead and do it. And it puts it down here at the bottom. Now, we're going to get into actually understanding the SQL dialect here in the next lesson, but I wanted to show you that you don't even know any SQL in this program and that you can just query it using the actual UI. And it puts in all the relative information, all these different column names for this data set. There are a lot of columns in this one. And then down at the bottom, it provides a table view of this. And I can go through and see all the different values in it. And also scroll down because it returned, I see from up here, 100 rows returned in 374 milliseconds. DuckDB is super fast. If I wanted to, I could copy the results to my clipboard or even download the results to some different file formats. Now, what's cool about this UI that I really like is that over on the right-hand side in this inspector window, I can go through and view all the different columns right here, and it provides some EDA or exploratory data analysis for me to actually dive into it. So looking at something like the country column, it tells me that there are 28 distinct values. And it shows a bar chart with this, how it relates to the other columns and how many distinct values it has. And we can scroll through and see any different column we want. This has, like I said, this has a lot of columns in it. So this is great for someone that wants to actually look through a lot of different columns. Now, besides viewing columns right here on the inspector, you can also view it down below here. If I just click survey results right here, it will appear right underneath it. And once again, I can actually, in this case, we can see that there's a difference here, right? This one, because we only queried 100 rows, 100 of all the different rows that they have, it only showed 28 columns. But over here on the left, because this one actually queried all 615,000 rows, it has different results. And it says we have 264 different countries. So make sure you understand what we're actually querying whenever you're viewing this in either one of the windows. Anyway, I can also go into and dive into seeing a deeper dive on any one of these as well by just double clicking on it. So if you notice when we're going through that, none of that jobs data that we're going to be using for the course is located in here. We actually need to attach that database so that way you have access to it. So what we're going to do is we're going to navigate over to this notebook that we're going to be working in for the remainder of this lesson. That's on that 1.1 SQL and database setup that we created. Inside of here, inside the notebook, we're going to add a cell. Now we're going to run an attach command in order to attach a database. Specifically, we have to specify this long line in there. So I'm not going to expect you to actually type that in. I'll include it in the description below for you to just copy and paste into here. And this is actually specifying that data jobs database with a unique identifier. From there, we're going to run our first cell by pressing either this button up here, this play icon, or we can press, in my case, I'm on a Mac, I'm going to press Command Enter. Now we can see up in the left-hand corner is my data jobs database. It has only one schema in it of main and then 4 different tables. Company dim, job postings fact, skills dim, and then skills job dim. So in our case, this is what the database hierarchy looks like. We have our schema of main and then those 4 tables underneath that schema. This is all within the data jobs database. Now, going back to this diagram you saw earlier in the course, this is how all the tables are related. We'll have a separate lesson on how to actually read this diagram, but the main thing to understand here is that this job postings fact table is our main fact table, and then these other 3 tables on skills and company provide skill and company information, and they are a dimensional table. So they provide extra attributes, but the core of the information's in our fact table. So for the next few lessons, we're going to be spending the majority of time in that job postings fact table. Once we get some basic SQL down, we'll get into how these actually relate, how to actually join them, what the heck this PK and FK actually mean. So let's actually inspect this data. So I'm going into job postings facts, selecting these ellipses here, and then go into query in current notebook. Now, some other things to note with this, right? We have up in the right-hand corner, it tells us which database we are connected to. That first one up here was connected to MyDB, but that's okay. It's an attached database. It doesn't really matter which database we were to attach it because it wasn't there yet. Anyway, that's really important to understand which one we actually have right here to actually execute the query because it may prevent you from executing it. Anyway, from there, it also provides underneath it those 100 different results and the different information. What I want you to do, because there's no practice problems for this lesson, what I want you to do from here is just spend some time inspecting this table, understanding the data set itself. Also, feel free to use the Table Explorer in there to actually dive into and see these different columns and explore them further. Specifically, you could do something like dive into what's this job title short column. You could see all the different job titles available and what amount they actually take up for the data set and how many rows. So that wraps up this lesson. You should have signed up for MotherDuck, got into the UI, and attached that data set. In the next lesson, we're going to be diving deeper into understanding the basics of SQL syntax, so you can actually understand these SQL queries that we just ran here. With that, see you in the next one. Welcome to this lesson on basic keywords. By the end of this, you should be able to, well, understand the basics, but be able to read basically any SQL statement from here on out, because a lot of the keywords that we're going to be covering in this are used time and time again in SQL queries. Real quick plug before we get into it, and that is to my course notes that you get in the supporter resources. If you haven't purchased them already, they actually go through and describe everything that we're going to be doing in an associated lesson like this one, and then break down the lesson step by step with even more detail. Anyway, I digress. Let's get into it. And the first keyword or keywords we're going to be covering are select and from. And this is how you actually read this. Select identifies the columns or data from a database, and then the from statement or from keyword identifies the tables we are connecting to. Now the asterisk in this case is a special command that says, hey, we want to select all the columns, everything. So in the case of our job postings fact table, we could do select star to select all of this from job postings fact. And showing this visually, we can execute this to get the results. Let's actually do it for real. So inside of MotherDuck, I'm gonna go ahead and create a new notebook. I'll call this 1.2 basic keywords. I'm gonna start a new cell, and conveniently it automatically selects our last database that we were using of data jobs. For this, I'm gonna type in select and then star from job postings fact. From there, I can press play or use these different shortcut commands to run the cell. If you're on a Mac, you can press Command Enter. On Windows, I think it's Control Enter. And this outputs all the results down below it. And it even says that it returns the first 50,000 rows in 926 milliseconds. Now, this is not all the rows of data. Thankfully, it caps it off to sort of limit the data. But if I scroll over here on top of job posting facts, I can see that our data set has over 1.62 million rows. One quick note on the syntax, you notice I use uppercase letters here and lowercase letters here. That's pretty standard. But if you wanted to, for the keywords itself, you could use actually lowercase letters. And in this case, it's going to still return the same results. So I can also change from, press Command Enter, and bam, same results. I could also change the table name itself to be all caps and still going to run. But specifically for table names and stuff, it's very important that you stick with that syntax of the lowercase because many databases require it to be what it is, the same syntax. And for keywords, it's just best practice to use these as all caps. It also makes it a lot easier to read. Now, of our job posting table, let's say I want to select specific columns such as job ID and job location. Well, instead what I can do, instead of using select star, I can list out the columns or column names and then still live that from of what the table is. So back inside Mother Duck, I'm going to put in that job ID. I'm going to just run this real quick. You can select one column. If you want to select multiple different columns, you would need to enter in a comma and then from there add in the next one that you want to use of, let's say, job location. And you can see we have some hints coming up as we type something. If I know, so I do know I want job location, I'm just going to press Tab and it's going to accept that. Anyway, I'm going to go ahead here and press Command Enter, and now we're getting that job ID and job location. Now, I like this a little bit more readable, so I'm actually going to enter job ID and job location onto the next line. And then from there, I'm going to press Tab to indent each one of those over. I can also do that with the from statement here and press Tab as well. Now, this does not affect the execution of the query. I can still run this. It provides the same results. I can also do multiple different indentations on different lines, just like this. And when I press play, it's still going to run. It doesn't really matter. This is all just for my readability. And also if I make a good query, it's for my coworkers' readability. Now it's very resource intensive to the computer itself if we were to continuously always pull all the columns from a data set. So in this case, if we wanted to just pull the top 3 rows, we'd need to use a keyword to limit it to that. Well, conveniently, we can use limit, and limit goes at the very end of your SQL query. And you specify the number of rows that you want from this. In this case, return those 3 rows. So inside of our query, I'm gonna go in and put at the very end, I'm gonna put a limit of, we'll just do 10, press Command Enter, and run this and only get 10 rows returned. Anytime you're building queries on large databases, you need to be using this keyword. You can always remove it at the end after you built it and verify that it's working properly. You'll save your boss a lot of money. So going back to this diagram where we showed the database container, its schema, and the tables and the hierarchy for it, we can specify any one of these things, assuming they're in the appropriate order. So right now we have the database and then the table. Remember, we also have something like the schema itself. So you could specify the schema in here as well. Whenever I run it, runs just the same. Updating the other portions of the query for this, it works just fine. Now, in the more advanced lessons, we'll get into when you need to put this nomenclature inside of here, maybe whenever we're joining different tables. But for now, I just want you that in the back of your head. Next up, let's say we have the scenario where we want to look at distinct values or unique values inside of a column. Take, for example, our job title short column. In here, we have things like data analyst, data engineer, data scientist. Anyway, we got millions of rows. We want to get the distinct values out of there. Well, we can use the distinct keyword right after select, and it specifies, hey, we want distinct values from job title short. So for this, I'm going to select distinct values of the job title short column. And we're going to be getting that from that job postings fact table. Running Command Enter, scrolling on down, we can see we get 10 rows returned. And just so you understand the concept behind this, originally I'm actually going to remove this distinct keyword right there. And I'm going to throw in the job title column, press Command Enter. The job title column is the actual name listed on the job description. and it can get pretty verbose. And so if I wanted to pull out like all data analysts or all business analysts, it could be a hassle doing this. So I created this job title short column in order to make it easy for you for analysis and building pipelines. Now with any of these queries, you want to end them. It's best practice to end them with a semicolon at the end, running Command Enter. It's still going to have the same results. And I can even put into something like a second query underneath this for those distinct job titles. Now, whenever I run this one, it will execute both queries, at least here, but only one of them will return. And I can see that by saying, hey, 10 rows returned, but 2 statements ran in 3.5 seconds. When we get into building out data pipelines towards the end of the course, these semicolons are going to save your butt. Next up, let's say we want to get specifically filtered job titles. In our case, we want to get them where they have the job title short of data engineer. Well, in our case, we can use a where keyword, and we put that directly after or from. And in that, we're going to specify via an expression saying, hey, we want from the job title short column values equal to data engineer. And it will provide those filter results. So inside of our query, we're already selecting the job title short and the job title. And we want to inspect further what are some other job description names for data engineers. I can then press enter. We'll put in that where statement, and we'll say that that is for the job title short column with it equal to data engineer. Now I'm going to go ahead and execute this and press Command Enter. We're going to get an error here. It says parser error, syntax error at or near engineer. The problem, as we're getting help from AI inside of MotherDuck, is that we don't have these single quotes. You can actually just, if we want to, accept and run by clicking this or pressing, in my case, Command Enter, and it automatically updates it for this. And then inspecting it further, we can see all the different job titles for data engineer, and they have a lot of different random ones. With this syntax structure of the where statement here, it doesn't matter. I did those spaces in there for readability. This is still going to work like this, but I like to have spaces in between, just make it a little bit easier. Now, the single quotes is not applied to everything. That's just text values. Let's say I'm going to add in the salary year average column and go ahead and run this bad boy. And then for this, I want to filter that salary year average column for, let's say, a salary value. We'll say salary year average equal to, let's go something like 100,000, press Command Enter. And now scrolling in through this, we're seeing all these different jobs that come in at $100,000. In this case, we did not put any quotes around this because this is a numerical data. And if we were actually curious to learn what's text data, what's numerical data, we could actually go into job postings fact by double clicking on it. And over on the side, we can see that the different values has different things. Specifically for salary year average, we can see that it has a number next to it, and also it calls out that it's double. Double, it's a type of data type that we're going to go into in a future lesson. But something like job title is a text character by this text symbol. We can see that it is the type varchar. Now we're going to change things up a little bit, not necessarily go over a keyword in this case, but a special marker that you may see in data sets, or that you will see in data sets. Actually, I'm going to remove this where salary year average statement from here and then press Command Enter to run this. And if you remember from what was returned, or if you actually do it, you can see that salary year average column, it has null values. And null is a special marker where a field does not have any value in it whatsoever. It's not zero, it's not anything, it's null. So it's very common that I want to filter for this. So I'm going to add back in that where statement that we had. And I want to filter for, in this case, I want to filter for null values. Now, you would think you would want to do, hey, we want to do where salary year average equal to null. But if I go to run this, press Command Enter, I'm going to get 0 rows returned. This didn't work. What you actually have to use to specify that you want this null is this operator of is. Running Command Enter, now we actually have the results of all the different null values here. But if you're like me, you don't really care about those null values. You actually want to get values that are not null. So if you can use this is operator, you can also use this not operator. Running this, we're filtering now for salary year average that is not null. And now we have nothing but numerical values in here that we can go through. Now don't worry if you're getting too freaked out by these operators of this equal sign, is, and not. We got a whole lesson on it coming up next. Now another concept to cover that's not a keyword is commenting in code. Let's say I build this spectacular query and I want to share it with others, but they may not understand what it is or even how to read it. I can put comments inside of the code, specifically by putting these double dashes. If you're in the military, double tags. And I can write something like, this is a comment. You can even see inside of here that it's formatted differently in this italics. But whenever I run this, it's still executing. And this doesn't matter if it's up on the top, off to the side, or even down at the bottom right here. No matter what, it's going to work. What I really like about this too is anytime I'm troubleshooting code, I'll usually use a commenting to comment out. So I can comment out like this line right here. Now when I run this, I only get the job title short and the salary year average column. Now let's say I have a multi-line comment going on here. In this case, I have a description of what this query does, of what field to select, what it filters, and shows some cleaning results. Anyway, this is really annoying to have to go through and execute these comments every single time inside of here. And so what I could do instead is use a multi-line comment. It has a / and then an asterisk. And if you notice by that, everything in this block is now marked as a comment. So I need to mark when that comment actually ends by using an asterisk and then another /. And that stops it. Now, whenever I run this, Command Enter, boom, I have it all below and I don't have this all commented off and it makes it a little more readable. The last keyword that we're going to cover in this is order by. And we can, as shown in this example right here, we have a column of salary hour average. We could sort the entire data set or whatever we select by that column using the order by command. In this, we're going to put order by at the end of our query, but before our limit, we have a limit on there. And we can specify the column what we're going to do. And automatically, it's going to do this in ascending order. So for this, I've selected the job title short column, job location, job via, and salary year average. And we're going to be going from the job postings fact table. And we want to order by, so I use order and then by, and then enter in that salary year average column. Running this query, we can see that the salaries in this case start at around 15,000 and then work their way up. So it's in that ascending order. Now, conversely, we can also look at it in descending order. And we do this by, at the end of the order by, specifying DESC or descending. So inside of here, I can just type in DESC, press Command Enter, and it sorts it into that descending order, starting with that first and highest salary of $960,000. Wowzers. Now, just a note, you can also specify ASC for ascending and provides the same results that we saw previously, but ASC is redundant because you should know that it automatically does it automatically, so we don't include it on there. Now, there is a certain order, or you'll get errors that you need to put these keywords in that the machine actually expects them to be in. Selecting from gets pretty easy and redundant. But when it gets to these other keywords, some of which we haven't even covered yet, such as group by and having, it takes some trial and error, but over time you do understand what type of order this goes in. It just sort of takes trial and error. Now, the order that you write commands is important. What happens if I wanted to, in this case, take that order by, stick it right here, and then try to run it? I'm going to get this. We get a parser error, syntax error, at or near from. And even the AI auto suggestion is not actually fixing for what it needs to actually do in this case. It thinks we need to change the order by to a from. This is why it's important to understand that you need to understand that there's an order to write commands. Specifically, this order right here. Select, then from, then where. Group by we haven't covered yet, or haven't covered yet. And then order by and limit. So let's say we wanted to get the top 10 highest paying jobs for data engineer roles specifically. Well, the first keyword we know you can use is where. So we'd specify that job title short equal to data engineer. After the where, we know we can then also specify the order by. And in this case, we want to get that salary year average, and we want it from highest to lowest, so we need to specify descending order. And then finally, we'll put in, we want the top 10 results, so we'll do limit of 10. And for good print measure, we'll put in a semicolon, press Command Enter, and we're not getting anything. And that's because I fat-fingered engineer. I'm not spelling it right. I need to put an N after this, actually running this again. Okay, now we're getting those top 10 jobs. Now I routinely switch this up and always will sometimes put the order by before the where, and you'll go to run this and you won't get this. And it's really important that you understand the ordering because the actual syntax message isn't very helpful at all in helping you fix this. So I'm gonna go ahead and just move that down below. Running this again, Command Enter, we have the results that we want. Now, throughout this course, I'm going to refer to something called DuckDB friendly syntax. And basically, DuckDB is super great because it's not only fast, but they also have a lot of ways to make it a lot easier to write your code. But unfortunately, a lot of the ways that you can write your code in DuckDB, you can't actually write in other databases. So that's why I call it friendly SQL. One quick example of this is if, say, I wanted to investigate that company DIM table, and I click the 3 dots and go query in current notebook. If you dive into this query right here, you see that in fact, well, one, they wrote in lowercase, which is crazy, but 2, they put the from statement up at the top. And if you remember from my order to write commands, from is clearly below select. Now this generalization is applied, so that you understand it, is applied to all databases beyond just DuckDB. But DuckDB has this friendly SQL that allows us to actually do this and put the from before. So that's why it's a little bit different here. So from time and time again throughout this course, you'll hear me refer to certain things as, hey, this is a friendly SQL syntax that only DuckDB allows, because I really want you to come out of this course being able to be database agnostic and be able to work in any single database. All right, for those that supported the course, you now have inside our dashboard, you have some problems to go through and get more familiar with operating all these different basic keywords. The last problem gets pretty spicy, so good luck. With that, I'll see you in the next one where we get into operators. In this lesson, we're going to be getting into operators. We're going to be using this to perform some exploratory data analysis on our data set. And we have 2 types of operators we're going to be using, of comparison and then logical operators, in order to dive further deep into it. Let's get into it. So let's just briefly cover both. And first up is comparison operators. These are the foundation of data filtering in SQL, as we saw in the last lesson using the equal to operator. Now we're going to be diving into these in this table, with the exception of is null and is not null we covered in the last lesson, and the like operator we're going to cover in the next lesson on wildcards. The other type of operators are logical operators, and they allow you to combine multiple conditions to create more sophisticated queries. Instead of having to run multiple queries, you can combine it into one. We're going to be looking at and, or, and not for this one. Now, in this lesson, we're going to be using it specifically in that where clause because we covered in that previous example, and it's the easiest one, frankly, to get an understanding of the concepts of these operators. However, I want to be clear in that you can use it, and we will use it in the future in other keywords such as having, joins, and cases. So these operators are not going away. They're going to be the foundation of what we need to use for the remainder of the course. So for part 1 of this, we're going to just cover the easy ones of equal to, not equal to, greater than, less than. And for these examples, we're going to be filtering in order to meet certain conditions as going through if we were searching through these job postings from the perspective of a data engineer. Inside of Mother Duck, I'm going to go ahead and create a new notebook. We're going to call this one 1.3 operators. In here, I'm going to start a new cell. I'm going to start with a standard query that we're going to carry out through the rest of this lesson. In this, we're going to select certain columns, specifically that job ID column, additionally job title short, job location, JobVia, which is like the online platform that we're going to be using for this. As you'll see, that lists platforms like LinkedIn or Upwork or anything like that where jobs can be posted to. And then salary year average, because we care about salary. All of this is going to be coming from that job postings fact table. So we'll go ahead and run this, pressing Command Enter just to see what we're getting here. And I'm going to close out of this pane right here and also zoom in a little bit so we can see a little bit better. Anyway, what I like here is we have the inspector over on the right-hand side that we can dive into any of the different attributes with. And it looks like, yes, the query below here only shows 50,000 results, but in the inspector, we can see that there's a total of 1.6 million. So the first thing we want to do, right, we're going to eventually get into data engineer jobs, but I want to see remote jobs. And so we could use this job location column and filter for that using a where clause, specifically specifying the job location equal to, we're going to say anywhere. For this, remember we need to put it as a string. We need to put it in quotes. And this comes back and it looks like we get about 144,668 rows. Now, I want to get remote jobs, and I actually want to call out something real quick with this. This is why we're actually doing this. If I copy this query and then I create a new cell, paste this in, what we do have is in this data set, we actually have another column called job work from home. And this is a Boolean value column, whether it has true or false values. And we want work from home values that are equal to true. I'm gonna go ahead and press play. Now this is going ahead and return the results, but I'm understanding right now that maybe you don't understand what this Boolean value column is. I'm gonna just go ahead and add it in. So I'm gonna do a job work from home, add it in, run this query again. And it now adds in this job work from home. I can actually scroll over and see it. And we see all these different true values because we filter for true. Boolean being true or false. Anyway, this one for filtering for job work from home equal to true, which would be a remote job, we have 144,532. Whereas if we scroll up to this one has almost 100 more, even though this job location is anywhere, thus a remote job. So we'll be able to actually identify the discrepancies of what jobs are marked as, well, anywhere, and also are not necessarily marked for remote work. This is an AND condition, and we're going to be covering it in our logical operators coming up. Next up, let's look at the not equal to operator. And for this, we can use two different types here. You can see here, it's either an exclamation point and equal sign, or basically like two Pac-Man eating each other. For those data engineers that we're eventually going to filter for also with this, I want to look at, let's say I want to look at just contractor jobs. So going back to that base query that we have already, go ahead and run this. I'm going to add into here the column that we're going to be filtering for, and that is the job schedule type. Running Command Enter so we can actually see this one. We can see down and over here at the bottom of the column, it has different values inside of here. And I actually can go in and inspect it further, selecting job schedule type over on the right sidebar. And we can see that the full-time has 1.42 million and contractor has 75,000. So what I can do is I can filter an aware condition on job schedule type equal to contractor. Running Command Enter, we get our results at 75,000 that's with all of them being contractor. But we want not equal to contractor. I think I said equal earlier. Anyway, in this case, all we need to do in our query is do a exclamation point equal to for the not equal to. And we get about 1.5 million results. We could also do the two Pac-Man eating each other and run this as well, and same amount of rows appears. Now, because I think you're getting the gist of this, we're going to briefly cover greater than or less than operators. In this one, we'll start with that same base query of job ID, job title short, job location, job via, salary year average. And we're going to filter our salary year average column. Let's say we just want jobs greater than 100,000. So we do where once again, specify that salary year average and say greater than 100,000. Running this below, we scroll over the column. It looks like it's about correct, but we can actually verify it's completely correct by going over this inspector panel. We can see that they actually start over at 0.10 million to 0.12 million, which actually, looking at the statistics at the bottom, we can see that it starts at 101 $1,000 because it's greater than. Whereas if we want to do greater than or equal to, running this now, Command Enter, inspecting this column, we actually get a min value of 100,000. Conversely, instead of doing that greater than or equal to 100,000, we could do less than or equal to 100,000, and we could see all the results less than that. All right, we're going to take a break from comparison operators real quick and dive into logical operators to actually start combining conditions. We have three ones we're going to cover in this: and, or, and not. The and operator only shows records when both conditions or all conditions are true. In this case, we have terms A and B. And then we have this nice little fancy Venn diagram off to the side. Unless they meet both of those conditions, it's not going to be included in it, so it's quite limiting. So we're going to be looking for data engineers, which would be term A, and then also remote positions, term B. And if they meet both those conditions, we'll get it. So starting back with that base query, we're going to be filtering where. Remember, we want to do two things. So first thing is for data engineers, using that job title short column, we're going to use the equal operator to set it equal to data engineer. And now we want to include another condition. So I'll do and for this, we want the job work from home column, that Boolean value of whether they marked it as remote or not, equal to true. And I'm going to go ahead and run this, press Command Enter. And we can scroll down and see this, or I can actually dive into it off to the side. We can see all the values are data engineer. And for the job location column, all of them are anywhere. One quick note on this Boolean value, you could also do a lowercase true like this. That's going to work just fine. I like to use all caps. It's pretty standard and it makes it stand out. Additionally, with this multiple conditions, I usually indent this down to the next line to make this a little bit more readable, and it still works the same. Now, because we understand now the and keyword, we actually can investigate that issue we saw previously, where we had for a job location of anywhere, we had this many values. And then for the condition of just job work from home of true, we had about 100 less values. So I'm pretty lazy. I'm going to go ahead and copy this job location anywhere up here. And inside of our query, I'm going to replace this data engineer portion that's going on. I'm going to run this because now we're going to be looking for job location of anywhere and remote jobs. And so we have 144,000. Well, where's the discrepancy at? And that's with we know that the anywhere column or the anywhere for job location has more values. So there are some values that are marked remote or that were marked anywhere that actually were marked false in the remote value. Running this now, we get the 140 rows. So now we have a list of the 140 jobs that are maybe marked incorrectly as job work from home because they have the job location listed as anywhere, but yet the job work from home column is false. Next up is the or operator, and this only shows records when any of the conditions or either of the conditions are true. This would be the case if I'm looking for multiple different conditions. Say I'm looking for not only data engineer roles, but also senior data engineer roles. Starting with that base query, and if I go into and investigate the job title short column of this 1.65 million, we can see we have about 392,000 data engineer positions and around 91,000 senior data engineers. So we can use or to get both of those. So I specify where, and then for job title short, we want it equal to data engineer. Then on the next line, we're going to enter that or operator. Specify for the job title short, we want then senior data engineer roles. Go ahead and run this. And inspecting that job title short column, we can see we have both of those options. Last up on logical operators is the not operator. This thing can be used all over the place, and it's a way of excluding